Hi students. So I assigned this extra credit opportunity. Of course, it's entirely optional. So I'm going to go to that. Here's our last week, week 8. And I'm going to go to that geometry review. And you know what is one of the best kind of extra credit opportunities? And it's one where I do it for you. So I'm going to be making a short video series. The goal is to have each video be about 30 minutes, but we're going to walk through this review packet together. And part of my reasonings for doing this is that I don't want to ask y'all to do anything that I'm not willing to do myself, and just kind of checking the difficulty levels as I go, and want to have this as a parting gift. So let's end the school year on a good note where we make things easier, not make things difficult. So I'm opening up my review in my note-taking app because I don't like the Canvas note-taking app, and it accidentally added to the gradebook. So here we are. So I'm gonna read everything, just walk through things the way I would expect you to walk through it as a student. So topic 1, right triangles. In a right triangle, the sides that form the right angle are the legs, as shown. And the side opposite the right angle, opposite where you can like draw an arrow through the triangle, that is a hypotenuse. So here's our hypotenuse, here's our legs. So we have to identify the legs and the hypotenuse of the right triangle, and it's actually done for us. Side A and B are legs, and side C is the hypotenuse. And so the way this triangle is labeled, it sets us up to use a squared plus b squared equals c squared, to use the Pythagorean theorem. So in these first problems, we got to read the instructions. It says, identify the legs and hypotenuse in the right triangles below. So we just have to label them or list it out just like it was listed above. So side X and side Z, those are the what? I'm sure you know, those are the legs. So easy review. And that means that side Y is the hippopotamus, the hypotenuse. Then we go over to this other right triangle and identify what's the legs, what's the hypotenuse. So side O and side M are the legs, while side N is the hypotenuse. Not the hippopotamus. Not that. It's the hypotenuse. Not this. That kind of looks like a pig, but it's a hippo. So then it just tells us to use the Pythagorean theorem. It just says, hey, use this formula to determine the missing side. So we have 4 squared plus 3 squared equals what squared? Well, that equals 5 squared. And this right here is a Pythagorean triple. And I'm going to reckon the ones on the bottom are also Pythagorean triples. They are. We're just going to work with integers, no decimals, no radicals, just beautiful integers that are going to work out fine. So if you don't remember it, it's totally fine. We can work that out. 7 is a leg, so 7 squared plus 24 squared equals c squared. So remember, it's not just a plus b. A and b, they have to be legs. Leg squared plus leg squared equals hypotenuse squared. So we're going to work this out. 7 squared, y'all know that's 49, plus 24 squared is 576 equals c squared. So 576 plus 49 We added it together. Y'all always add faster than me. I'm sure you already know what it is. It's 625 equals c squared. We take the square root of both sides because we are not interested in c squared. We're interested in c. Take the square root of both sides, and we get 25. So c is 25 units long. And so in this one, we had to find the hypotenuse. That's where you're probably most comfortable using Pythagorean theorem. But over here, we have to find the leg. So our process is a little bit different. So when we have to find the leg, what we're going to do is we're going to say 12 is our a. So 12 squared plus b squared equals 13 squared. Because remember, legs always go here. The legs always go here. I'm going to keep with my color scheme. So 12 squared is 144 plus b squared equals 169. That is what 13 squared is last time I checked. So over here, we just added, and it was great. We added and took the square root. Now we're going to subtract and take the square root. So b squared equals 9 minus 4 is 5, 6 minus 4 is 2, and 1 minus 1 is 0. So b squared equals 25, and y'all already know what b equals. It equals 5. So just some light review on right triangles. Great job. Sure it was easy for you. Probably didn't need my help there. And so here we have some more Pythagorean theorem. It says the Pythagorean theorem states that in a right triangle, and only in a right triangle, the length of the longest side, the side opposite the right angle, and called the hypotenuse, or c in the formula, so the length of the hypotenuse squared is equal to the sum of the squares of the other two sides. The sides that meet and form the right angle called legs, or a and b in the formula. The formula is a squared plus b squared equals c squared, or in other words, leg squared plus leg squared equals c squared. So up here we're dealing with just pretty little integers. Here we're going to be dealing with some uglier numbers, and it's going to be okay. I'm here to help you out. So here we go. I'm actually just going to do decimals because, we didn't talk about radicals that much at all. And so we're just going to do decimals, and I'm going to have to be okay with that. So here we go. For this one, you shouldn't even need to write the Pythagorean theorem down because we should be very good at recognizing this Pythagorean triple. 3, 4, 5. X equals 4. 3, 4, 5. It's a triple. So anytime you see a 3 and a 5, where 5 is the hypotenuse on a right triangle, that other leg is 4. Another example, anytime you see a 3 and a 4 on a right triangle, where those are the legs, the hypotenuse is going to be 5. So that's triple. We're done. But let's go on to number 2. Our legs are 4, and we need to find the hypotenuse. This is our A, this is our B. So 4 squared plus 4 squared equals y squared, or c squared, whatever you want to put. We're gonna get the same answer. 4 squared is 16 plus 16 equals y squared. 16 is 32 equals y squared, and so y is the square root of 32. Because to get rid of the squared, we have to take the square root. Now we're not going to leave it there. Let's go ahead and find our decimal. Square root of 32 is a number, and it is 5.66. 5.66 what? Well, look at you. You saw the units. You knew that it was feet. So there we added because we were finding a hypotenuse. Now for number 3, we need to subtract somewhere in our problem solving because we're finding a leg. So it doesn't really matter if you let x be a or b. I am going to let it be a. So x squared plus 8 squared equals 17 squared. 8 squared is 64, x squared is x squared. And 17 squared, what's that? Oh, it's 289. We knew we were going to have to subtract somewhere, and this is where it's at. In order to solve for x squared, we have to subtract 64 from both sides. that lets us know that x squared is 225. Now we're not interested in x squared, we want to know what is x. So that means we have to take the square root of both sides. And we get x equals 15. So x equals 15 what? That's right, centimeters. Let's do number 4. This is a triple. I know the answer, but maybe you didn't memorize your triples. I probably wouldn't memorize them either if I was doing online learning. So let's just work it out. It won't take us too long. 5 squared plus 12 squared equals x squared. 25 plus 144 equals x squared. 169 equals x squared. X equals 13. Great job. So here's our next one. And it's also a triple. So if you've been paying attention, you're like, oh yeah, 5, 12, 13, 7, 24, 25. But if you're like, I don't believe it, I don't understand where you got 25, hey, Pythagorean theorem still works. You don't have to memorize those triples. But since I keep talking about them, let me list them out. 3, 4, 5 and all multiples, 5, 12, 13 and all multiples of those numbers, and 7, 24, 25. These are ones that you'll see all the time. And if you notice, we actually figured out the 7, 24, 25 up here. And this one was a 5, 12, 13. So you'll see those a lot. In fact, I'm just going to set it up, but I'm not going to work it out because we literally just worked this out above. So 7 squared plus 24 squared equals x squared, and x is 25. 25 what? Inches. Cool. That was fun. Now, number 6 is just like number 2. Now, if you did a really great job in that week 3 unit, you understand that 2 and 6 are actually special right triangles. They're 45, 45, 90s. They are isosceles. Remember, isosceles means 2 congruent sides. We can mark that with a tick mark, in fact. 2 congruent sides. So they're isosceles right triangles, and they have special properties. So we learned that when these match, that this side is 4 radical 2. And so if you type that in your calculator, these are actually the same thing. And so based on special right triangles, we can kind of conclude that this is going to be 10 radical 2. But I'll prove it to you. We'll make sure they're equal in our calculator and all that fun stuff. So let's just stick with Pythagorean theorem, though, just to get it set up, and then do some discovery in just a bit. So a squared plus b squared equals c squared. Leg squared plus leg squared equals hypotenuse squared. Let's set it up. 10 squared plus 10 squared equals y squared. So 10 squared, that's 100, plus 100 equals y squared. 200 equals y squared, but we want to know what is y, so we take the square root of both sides. And the square root of 200 is approximately 14.14 meters is what we get for our answer. Now I'm just going to prove to you real quick that, hey, 10 radical 2 and 14.4 are the same thing. Look at that. It's 14.4. So special rights are shortcuts. That's all they are. You don't really ever have to memorize them. They're shortcuts. There's some instances where you have to use the properties, but in all those instances in your probably adult life, you will have the internet and calculators to help you. So moving on. Number 7, that's our last right triangle problem that we're going to do. And let's check it out. So we have 16 squared. That's going to be our A. I'm going to let this be B. And we know that the 50 has to be our C because it's our hypotenuse. So 16 squared plus B squared equals 50 squared. 16 squared, it's 256 plus B squared equals 50 squared, which is 2,500 or 2,500. So again, anytime we're looking for a leg, which we are, x is a leg, we're going to subtract. I guess this should be an x. So 256 minus 256. And we get that x squared is 2,244. Let's take the square root of that. That doesn't look like it's perfect square, so we're probably going to get a decimal. And that's okay. Or welcoming it for this particular review exercise. Extra credit opportunity. So when you take the square root of both sides, you get that x is 47.37. Excuse all my ums. I haven't talked to students in a long time. So 47.37 what? Feet. Great. So Pythagorean theorem. Did you learn anything? Was some of that easy for you? If it was easy for you and you're like, Miss, you're boring me, I know this, that means that you learned some stuff this semester and I'm proud of you. So let's move on to our next topic. We have about 10 minutes left, and this topic is perimeter and circumference. So perimeter, add up all the sides. Really that easy. The perimeter is the distance around an object. It is measured in linear units. So that means inches, meters, feet, miles, centimeters, etc., etc. So that's what perimeter is. To find the perimeter, add all the outer sides. Find the sum of the lengths of the sides. The end. Since 8 is the height of the triangle in this particular example, we're not going to add it. Don't add it. It's not a side. Don't add it. Just because you're given numbers don't mean you have to use all your numbers. That's like a common mistake that we will make all the time. Don't do it. Just don't. So it gives us some different formulas, like it says add up all the sides, or if it's a circle, you got to find the circumference, so do 2 pi r. And I want to just remind you that this is absolutely not, please don't do it, don't think it, is not 2 pi r squared. Get that out of your head. There's no squared. Squared is with area. Don't do it. I got a lot of people answered that for like, what's the formula for circumference? And they're like, 2 pi r squared. No, it's not. So it gives you these formulas that kind of use as shortcuts, but basics is just add up all the sides. So don't, if these confuse you, if these bother you, don't use them, period. You do have to use circumference, but if 4s like triggers you in any way, or you don't understand 2l plus 2w, like just add like normal. Okay? Anyways, so I'm just gonna add like normal. Maybe you might do some multiplication for this square. Y'all all recognize that this is a square, right? It has 4 congruent sides and 4 right angles. So how do I know the sides are congruent? Oh, right, because there's tick marks. Lovely. Good job. So that means that if this side is 7, then this side is also 7, and all the sides are 7. So if I want to find the perimeter, I'm not going to do 7 times 7. No, wrong. That's area. To find the perimeter, I'm just going to add 7 plus 7 plus 7 plus 7. So I can add all those numbers up pretty easily, but I want you to think about it in this way. repeated addition is multiplication. So how many times do I have to add 7? I have to add 7 4 times. So I'm just going to say 4 times 7. And that is where we get that formula. Okay? It's just using this shortcut. So 4 times 7, last time I checked, is 28. 28 what? I guess we're using units. So here we're going to add up all the sides. Are we going to add 4? No. Because 4 is not a side. 4 is the height. So we're going to add 5 plus 5 plus 6. So 10 plus 6 is 16 units. So notice how I wrote this out. A lot of students are like, I did it in the calculator, I did it in my head. Yet, I still like to see your showing work. And so show your work. Show it on the paper. So here we are finding circumference. So circumference, since circles don't have sides, we cannot add all the sides. So we must use a formula. 2 pi r. 2 times 3.14 times the length of the radius, which is 5. So 2 times 5 is 10. 10 times 3.14 is going to be 31.4. So 31.4 units is our circumference. That's the distance around this circle. So here we have a rectangle. We have 4 right angles in this quadrilateral that makes it a rectangle. The tick marks help us understand that if this side is 8, then the opposite side is 8. If this side is 18, then the opposite side is 18. And so we're simply going to add all these numbers. 8 plus 8 plus 18 plus 18. 8 plus 8 is 16. 18 plus 18 is 36, I believe. So 16 plus 36 it's going to give us 52. 52 units. You don't have to write out units. I didn't for any of the other problems, just felt like it this time. Now, this is tricky. We have to do some problem solving. We're not just going to add the sides given to us. It might be easy to be like, look, I added all the measures that were given to us. But if you do that and think you're done, you're missing out on 2 sides of the shape. So we need to figure out what are those lengths, and we need to add them in to our calculations. So how do we figure that out? Well, this entire length is 100 meters. From here to here is 61 meters. So we know that this is 61 meters. And so if we do 100 minus 61, it's going to give us this length, which will be the same as that length. So 100 minus 61 should be 39. So let's put 39 meters right there. Let me just confirm that. All right. Now we have to use the same type of logic and problem solving on the other side. So this is 30. This entire length is 53. And so if I subtract the 30, it's going to give me what's left over, which goes there. So 53 minus 30 is 23. Now that I have all my sides, let's add them up. So 30 plus 100 plus 53 plus 61 plus 23 plus 39. And we find that this figure has a perimeter of 306 meters. Find the circumference. So there's 2 formulas for circumference, right? So there's 2 pi r. Great. But there's also pi times diameter. And so these both will give you circumference. Why does this work? Because 2r is the diameter. Double the radius, you get the diameter. So we're just going to use pi d because we're given the diameter. So no reason to say, figure out, well, the radius, what is the radius? And then plug it into your formula, just use the diameter. So when we just use the diameter, we are going to be multiplying 3.14 times 12. So 12 times pi is 37 point, it's like 6.9. I'm using the pi button, so if you're off 1/100th, that's okay. I know the instructions say 3.14, but it bothers me, so I always use the pi button. All right. So we have another one of these problem-solving problems. I see that there's tick marks. So that side's 40, this side's 40. Great. This tells us the length from here to here is 30. And so if the entire length is 40 and this is 30, that means what is left over, if we subtract, is 10 here and 10 there. But we don't know how long this is. How are we going to figure it out? Well, the entire length is 93. This part is 44. That part is 29. So we're going to take 93 and we're going to subtract these two lengths and see what's left over. Well, let's do that now. 93 minus 44 minus 29 is 20. So this is 20. Now that we've done all that subtracting, we actually have to add everything up. So 40 plus 93 plus 40 plus 29 plus 10 plus 20 plus 10 plus 44. Now check it out. I'm adding 1, 2, 3, 4, 5, 6, 7, 8 sides. If I'm adding 8 sides, 8 straight sides, what's the name of this polygon? What do we call polygons with 8 sides? If you said octagon, you're exactly right. Wow. So let's find the perimeter of this octagon. Now if you're like, Miss, that don't look like an octagon, then what you're thinking about is a regular octagon. It's absolutely not regular, but it is an 8-sided polygon. So it is an octagon. It's just not a regular octagon. Anyways, moving on, let's add up that perimeter. So when I added everything together, I got 286 millimeters. Now, everybody makes mistakes, so check it out. Check my work. Make sure that you got the same thing. Now, the perimeter of the triangle is 73. So that means when we add up all the sides, it is 73. Now, something I taught y'all well before the break is that anytime you see the word is, you can translate that mathematically to an equal sign. Okay? Okay. So, the perimeter, okay, that's sum of sides. So the sum of the sides equals 73. So how about we sum the sides and set it equal to 73 so that we can do what? Solve for x. So here we go. X plus 6 is a side, plus 2x minus 8 is a side, plus 7 plus x is a side. So that's the perimeter. This is the perimeter. But that perimeter is 73. So a lot of students struggle here. We need to combine like terms. So 1x plus 2x plus positive x. That is 4x's. Great. And then 6 minus 7 plus 7. Minus 8 plus 7. So 6 minus 8, we know that that's negative 2. Negative 2 plus 7 is a positive 5. So we have 4x plus 5 equals 73. So this cleans up really nicely, but we can't just start adding and subtracting things willy-nilly. We have to make sure we combine things before we start our actual problem solving and doing our inverse operations. So since this is a positive 5, I'm going to do the inverse of that. I'm going to subtract 5 from both sides. When we do that, we get that 4x is 68. And divide that by 4 on both sides. And we find that x is 17. So x equals 17. Now check it out. This problem, you've learned to, if I were to ask you the question instead, solve for x, or if I were to ask you, find the length of each side, what would you do? You would take it one step further and plug 17 in wherever you see an x in order to find the length of each side. So, I hope you found this helpful and entertaining. I will get back with you tomorrow with part 2, and maybe even hopefully part 3 will come out tomorrow as well. Have a great rest of your Monday. Goodbye.